Imagine that you're going to send a ball from a height. So obviously it's going to reach a distance, right? If you send it with an initial speed or velocity. But it's easy to understand that if I send it with the highest velocity, so our ball is going to reach more distance, right? So if we assume that the Earth is a sphere and we send our ball, what do you think will be the velocity to make our ball to do a whole turn around the Earth? Hi, I'm Agofim, and today we're going to learn how to model situations using circular motion. Okay, so our question now is how we're going to model this situation and how we're going to explain and calculate this velocity. I forgot to put the arrow to tell that this is a vector. So in the first thing we need to bear in mind is that the velocity here in this type of motion, we're going to assume that it's going to move in circles. The velocity is changing its direction. So I'm going to paint here in red the first velocity, and then after some time the velocity will be here, okay? And if I move these two speeds to one position, I'm gonna have this type of change. So that will mean that we're gonna have an acceleration in this direction. Okay? So, but what we found here that anything or the object is changing its velocity, but maybe it's not in magnitude, but it is in direction. So the force in this situation, the force in circular motion will change the direction of the speed. Will change the direction of the speed. Okay, so that's going to represent that our force is focused to change the direction of the object, changing the speed. And in this way, the acceleration is going to change direction of velocity. Sometimes it's not going to change the magnitude of the velocity. If we go back to circular motion, it's easy to understand that the motion or the change of speed, it's going to be always to the center of the circular path. So if the velocity is here, the acceleration will be to the center, perpendicular to the velocity, and always to the center. Okay, so now we're going to do second Newton law to see how we can model the force and the velocity and the acceleration in this case. So if we apply second Newton law, we just need that the total force or the net force is going to be mass times acceleration. This is the idea of the second Newton's law. And in our case, the problem that I'm explaining to you, the only force that is moving the object will be mass times gravitational acceleration. Okay, that goes to the center of the object. So in this case, the force will be to the center of the object. And you can see in this case that the acceleration for any circular motion is gonna go to the center of the circle as well. So we're gonna have an acceleration that pulls the object to the center. So this acceleration is calling the centripetal acceleration. Okay, so, but you may ask, okay, but how to calculate the centripetal acceleration? Really, to do this thing, we need to use a complete video to explain how to demonstrate this idea. If you wanted to know, just send me a comment and I will prepare a video that explains how to achieve the centripetal acceleration. The centripetal acceleration could be calculated as minus b squared over r. Okay, r is the radius of the circle, b is the velocity, and it's going to go in the direction of the radius, but negative. Or we can also write it as minus the angular frequency to the second power times the radius in the radial direction. So if you have the circle, radial direction is pointed out from the center to any part of the circle, so it will be negative in this direction, will be centripetal acceleration. So if the centripetal acceleration is this, we're going to have that mass times gravity is going to be equal to mass minus b squared over r. That will be our expression to calculate any variable, and using second Newton's law I can simplify the masses in this case, and I'm gonna have that g, gravitational acceleration. I can also simplify the minus, so I'm gonna get that the gravitational acceleration will be equal to b squared over r. I know essentially g and r, so I'm going to solve for v. G times r will be b squared, and that means that b equals the root of g times r. Okay, so what we did, you may thinking right now, you may would be thinking, what we did, what is this about? What we did was to use the fact that the centripetal acceleration is through the center of the circle, and use the definition of centripetal acceleration to determine an expression that tells us the velocity we need to have in motion an object whose force applied is gravitational force. So right now, for example, if you think of a ball, so we're going to calculate the velocity of the ball that we need in order, if we send the ball, what will be the velocity we need on this ball to have a complete turn around the Earth. This is what we did. This is what you can see in the expression of velocity equals radius of g and r. Okay? And I think that this is awesome, because you can have the radius of the Earth. So maybe you may ask, okay, what is the radius of the Earth? So we can round the radius of the Earth. I'm going to do an estimation, okay? So radius of the Earth, it's about 6,400 kilometers. So if we put it in meters, 6.4 times 10 to the 6 meters. And g, it's about 9.8 meters per square second. So if you put these values here, you can use your calculator to find that the velocity is going to be 7.9 times 10 to the third power meters per second. So you're going to have 7.9 kilometers per second. Kilometers per second. 7.9 kilometers per second. So you need to throw your ball with a speed of 7.9 kilometers per second to make it move around the Earth. Could you imagine sending a ball to this speed? Could you imagine the force required to do that? That would be excellent to have some way to do it. Okay, it's difficult to do it, but this is the idea of the circular motion, and this is the idea of how to model situations using circular motion. Now, what we have learned today? You may ask, okay, what I have learned today? We have learned today 3 things. First, how to model a situation using circular motion. Second, how to calculate the centripetal acceleration, or what is the expression of the centripetal acceleration. And third, what is the speed of a ball that orbits Earth? This is what we have learned today. And I hope that you learn and that you can write in your comments if you understand what it means. Because it will be interesting if you think of a force of gravitational force when you're not close to the radius of the Earth. Like, for example, the force applied upon a spacecraft. That would be this. How do you think will be the velocity a spacecraft requires if we apply this force? Tell me in your comments. Right. One important part of working in science and math is to do your job. And part of your job will be taking data, take numbers. So my hint for you is to check what happened with the force and the centripetal acceleration. I hope that you enjoyed this video. I encourage you to like my video, to subscribe to my tube, to send me comments, questions. Maybe you want to do the exercise with the spacecraft, but you have problems. You can write me in the comments or send me emails to understand more about this part of physics that I think that it's awesome. So see you in the next video. These are some things that you can check to learn more about circular motion. Have a nice day and bye bye.